I saw this integral on YouTube. I have my own method to do it, and it's different. It might be better. I would like to share with you. Now, I call this integral I. I make another integral j, which is from 0 to a, natural log a plus x minus a minus x. Obviously, that I can combine I and j to create two simultaneous equations and then solve I. I plus j will be equal to this plus this, right? Then use the property of logarithm. It becomes a natural log. This time this. This time this one's a, this plus this one, this minus this one. So it's obviously it becomes a plus x minus a minus x. Correct? So this one is equal to natural log 2x, right? 2x dx, which is equal to uh, log 2. Log 2 integral is a log 2, right? That's the first one. And the second one is log x dx. Okay, that is my I plus j. Now then I create another equation I minus j so that I can solve for x, solve for I. So this one is equal to this minus that. This minus this, according to the log property, becomes a log this over that, right? This plus this over this minus x dx. Yeah. Then I multiply this, both numerator and denominator. It becomes this is square. This is square is a plus x plus a minus x, right? And plus twice this time this one, which is a square minus x square. The bottom will be this square minus this square, right? So a plus minus a minus x. Okay, then this becomes a 0 to a log. This is easy, is 2x. Right? This will be, this is a minus, huh? Sorry. X cancel out is a 2a plus 2. Yeah, good. Then I cancel x. I cancel 2, huh? So the first integral becomes natural log a plus this. And minus log x dx. Yeah. And let me consider this integral separately. Okay. A plus a squared minus x squared dx. I use a substitution, right? Let x be a sine theta. So dx will be a cosine theta d theta. So this integral becomes 0 to natural log a plus a sine squared. A take out and the cosine, right? Yeah. And a cosine theta d theta. Very good. Now then take a out, right? A out. The first integral is log a times cosine. Okay, let me not jump. Okay, log a times cosine theta d theta. That's the first one. The second one is plus natural log 1 plus cosine theta, right? And the cosine theta d theta. Because I take a out, so log a times 1 plus cosine theta, so it becomes this. Okay, this one is equal to a log a sine theta. Yeah. This one is a times integral there to a natural log of 1 plus cosine theta. This is a d sine theta. Okay. Very good. And this is equal to, this is this. Wait a minute. I have to change the boundary, okay? When x equal to 0, it's a 0. When x equal to a, theta is a half pi. Sorry. There's a mistake. I'm sorry. We learn from mistake anyhow. We learn from mistake, don't we? So this is half pi. Well, it's a obvious mistake, and it's a nice mistake to learn from. All right, and then this one will be 1, right? Log 1 is yeah, this is 1 is okay, then it becomes a log a, right? And 0 is a 0. Now for this one, for this integral is a from 0 to half pi natural log 1 plus cosine theta, and this is a d. This is what? This is a d sine x theta, right? So I can use by parts. So this was a log a plus a uv sine theta times log 1 plus cosine theta. minus integral, this time this derivative, v du, right? So it's a sine theta. This is a 1 over cosine theta times this derivative, which is negative sine theta. D theta, negative became plus, okay? So this one is equal to a log a excuse me. Continue. This is this is 0. Therefore, is log 1 is 0. When the theta is 0, this is 0. So everything is 0 here. And for that one, this is cos. This is sine square. Sine square is 1 minus cosine square, right? This is 1 plus cosine square. So this is a log plus. This is 1 plus cosine times 1 minus cosine. So left is 1 minus cosine. Okay, so this is a log a. This is theta, right? Plus theta minus sine theta. So it is a log a plus half pi minus 1. Good. This is my integral of this one. So now finally I can find I, which is equal to 1/2 I plus j plus I minus j. 1/2 I plus j is this. This is I plus j. Is a natural log a times natural log 2 plus integral log a dx. That is I plus j. I plus j. Now I minus j. I minus j is this minus this. This is this. So a log a plus half pi minus 1 minus this minus 0 to a log x dx. So this will cancel that one. So it's end up, this has a, this has a. Do I forget something? Yeah, we have a times this one, right? So this, we have a here. I'm sorry, here is missing something. A, so times a. Yeah, this times a, okay. So this one has times a. Then a is a common factor. Log 2 plus log a is log 2a. and plus half pi and minus 1. Yeah, there's a here, okay? There's a here. I'm sorry, there's a little messy, but anyhow, I think you can organize and rewrite everything together. I think you can trace back. Uh, I think it's should be okay, but you can trace back and to follow. Thank you.